All right. What I want to do in this little series of videos, everyone, is kind of recap the process or the steps of a hypothesis test, and then I want to walk you through each type of test. So I'm going to split those up and I'll make a separate video for each one of these examples. This worksheet that I'm working from is going to also be attached on Google Classroom. So just kind of a recap, a test of hypothesis is a statistical method used to test a claim made about a proportion or a mean. And so we have three types of tests. We have the one prop Z test, which is when we have a claim about a proportion. Okay, so that's you're dealing with percents or proportions. Then we have our two tests about means. We have a Z test and a T test. So both of these are a claim about a mean, and I should notice up here too, population proportion is going to be your P. So claim about a mean, so they're making a claim about a population mean, which is mu in both of these. So what we need to then be able to determine is when we're dealing with a claim about a mean, how do we tell the difference in these two? And it's much like when we did confidence intervals. So with a Z test, that matches a Z interval. So that means sigma is known, and sigma, again, is your population standard deviation. Here, sigma is unknown, or you have a very small sample size. Okay, and usually we say, if n is less than 30, we'll usually go with a t-test. 30 is about the cutoff. Okay, so in order to run a test of hypothesis, we talked a little bit about this already. We have what is called the 5-step process. So stating your null and alternative hypothesis is the first thing. So your null hypothesis is denoted by H sub O. The alternative is denoted by H sub A. If you're talking about proportions, you're going to use a P, and you're still going to have P in both of these. Now, the null hypothesis should absolutely always be equal to some number. Then your alternative hypothesis, this is where we get to say, okay, I know that you're claiming it's, I don't know, let's just say 30%, and I don't think that's right. So this is where you get to say, well, I think it's less than 30%, or I think it's more, or I don't know how it's different. I just don't think it's 30. So this is where you get the option of less than, greater than, or not equal to that same number. Now we can have the same thing with means. So in this case, it would be mu, because remember, these are the claims being made about the population. So this, they're claiming the population proportion is equal to something. We're claiming it's not. Over here, they're claiming that the population mean is equal to something. We're claiming that it's not. So these less than, greater than, not equal to, these are also what tells you your tails. Are you going to have a one-tail test? Less than is a left tail test. Greater than is right tail. Not equal is a two-tail test. Then you have your level of significance, which is alpha. And alpha is typically going to be 0.05 unless you are told otherwise. And as you remember from the video about error, this is your probability of committing a type 1 error. And this is 5%. This is also the cutoff for what is considered usual or unusual. And that 5% has to do with your critical value and test statistic. So for step 3, we've got critical value, test statistic, and p-value. So your critical value, it depends on whether or not you have a left or right tail test or a two-tail test. So I'm just going to do, for example here, a left tail test. So we would have a negative critical value. Anything beyond that critical value is considered the reject region. Okay, so if your test statistic falls outside that critical value, you get to reject the null hypothesis. Your p-value, if your p-value is less than alpha, you get to reject the null hypothesis. That means your probability of getting a sample like this, given that the null is true, is so unlikely that it raises some red flags and causes us to think, hey, maybe the null actually isn't true. If your p-value is greater than alpha, then you fail to reject. And so that's your decision, and these two things both help you make that decision. So then your last thing is your confidence interval, and you have three types of confidence intervals. You have your Z interval, your T interval, and your one prop Z interval, and those match directly with your Z test, T test, one prop Z test. Okay. Also, here is just a recap of the formula sheet. So remember, in general, we have kind of two different tests, a Z-test and a T-test. Now, your one prop Z-test falls under this general umbrella of Z-test. Okay, so no matter what type of test, you have your null and alternative that we just talked about. And for both types of tests, we have a critical value. So we have left tail, right tail, two tail possibilities for these. We have our test statistics. Now, this is the new thing that I just added. When I first made this formula sheet, I forgot to add that or put that on there. So remember I said one prop Z falls kind of under this general umbrella of Z test. So here is your test statistic for a Z test for means. This is your test statistic for a Z test for proportions. And then this is your T test. These pictures hold true for all of them. So just your left tail, right tail, two tail, and then how you find your p-values. And again, these work for both the regular z-test for means and the z-test for proportions. So just make sure you note that update and get that added to your own formula sheet.